In this video, we're going to work through some of the coding and syntax basics within R. So first and foremost, the first thing to know are what is called code chunks. And that is anything that you're writing in your code that ultimately will produce some sort of output. So here on the screen, we have what are considered code chunks, and then below each code chunk is their given output. So just as an example here, we have 1 divided by 200 times 30. And if we enter that into our console, what comes out is this, what is called an output. And so if we work through this equation, that would equal to 0.15. So that is what we see for these examples here at the bottom as well. So this, what is called code chunks, differs from comments, which is another thing that we can use within our code. And what comments do, like what it's called, it comments your code. And this is really important to do because they serve as notes within your script file and really used to enhance the readability and understanding of code, both for the original author and other users. You can imagine if you return back to your code months, years later, you might not remember exactly what was done, but with the help of comments, that helps you to understand or others understand what exactly you're doing with your code. To create a comment within your script file, you use the hashtag or the £. And here's an example here in this code chunk. You can see that the code, which is 50 divided by 2, that is what's considered a code chunk, and that will produce an output. But anything else where you see the text is actually in this orange-brown, these are called comments. And you can see the hashtag or the £sign in front of it. So anything following that £sign is considered a comment and will not be run when you press enter to run your code. Okay. So the next thing when it comes to creating code in R is using functions. And these are self-contained blocks of code designed to perform a specific task. So this is really where the power of R is. Functions take inputs, and those are known as what are called arguments. And to call functions, you use the function name and then parentheses with the arguments inside the parentheses to specify inputs and any sort of function specialties that you need. So here's an example of a function called sample. And the arguments that it takes are the numbers in which you want to sample. So this is 1 through 50. We want to sample the next argument, which here we provided 15. That means the number of samples that we want to take out of the numbers 1 through 50. And then here replace equals true. That means once you take one sample, put that number back in so that you can continually resample that number. You can also make it false if you'd rather not have that. But what I want you to grasp here is that functions are very powerful, and that is the beauty of what R does. Functions, they follow, parentheses follow the function name, and within the parentheses, you put the arguments that it calls for. Each function calls for different arguments. And a great way to learn more about a function within R is in your console to get a little help information around a function. You do question mark and then the function name. So for instance, here for sample, to understand what these arguments actually are, you could do question mark sample. That is exactly what I'm showing you here. So again, to find out more about how to use a specific function, what arguments it takes and requires, and other sorts of details, you can use this question mark and then sample. And this little screenshot here to the right of the slide shows the help screen that appears when you enter this question mark sample, and you can see the description at the top, the usage, so how it would look in your code, and then below you can see the description of each of the arguments that it requires. So extremely helpful when you're trying to learn more about how to use a function. Okay, so next let's work through how to assign variables. So Assigning variables in R, you can either use an arrow or an equal sign, but it's really common practice to use the arrow. And so here are some examples of how you can assign numbers to a variable. So here, say I've created what's called a variable called number_1, and I'm using underscore here. This is another common practice. You cannot have spaces usually in variable names. So that is why I use underscores. Some people use periods. It really just depends on what you prefer. The best practice here is to just be consistent throughout your code. So that is kind of an aside. But here we're creating this variable called number_1, and we're using the arrow here and saying assign the number 1 to this variable that I've created with number spelled out _1. And we do the same for number_3, assign this variable name the number 3. Okay, so that's assigning explicit numbers to variables. You can also use function outputs to assign variables, and that's what we see here in this next example. I've created a variable named sampled_numbers, and I'm assigning the output of that sample function that we used earlier in the previous slide to assign it to the sampled numbers. So if you run that, you should have that same output or a similar output that we saw, 15 random numbers from 1 through 50. Okay, and then lastly here at the bottom, you can also assign text or character strings to variables. So I've just created the name here, Coastal Zone Management Authority and Institute, as an example, and I've assigned it to this variable called CZMAI_full_name. Similarly, I've created a shortened name where it's just the acronym CZMAI, and I've named or assigned that acronym to this variable called CZMAI short name. Okay, so you can assign numbers to variables, function outputs to variables, text, really anything you want, you can really assign it to a variable. Okay, so another topic that I wanted to work through is what's called concatenation. Quite a tongue twister, but this is the process of joining or combining multiple elements into a single larger structure. And you can concatenate one way by using the paste or the paste 0 function. So we work through some examples here. Say we have these two character strings, string 1 and string 2. String 1 says R can be intimidating, while string 2 says, however, R is a powerful tool, period. If we use the paste function, which we're seeing right here, just paste, no 0, the arguments of paste is some variable 1, some variable 2, and then how you want them to be separated. So what I'm saying is paste together string 1 and string 2, separate it by nothing. I'm just using quotes here, and there's nothing in those quotes. Whatever comes after the sep, it has to be in quotes. So if you output that, it should say, have the output? No, I don't. It should say R can be intimidating, and you'll see that there's no space in between intimidating and however. That is the same as paste 0. That's saying there's going to be nothing in between these two strings or these two variables. Okay, but say for instance we want to make this look like an actual sentence. So we want a comma after intimidating and a space before however, like how a regular sentence would grammatically read. Then that is what we see down here at the bottom of full_sentence. So we've said paste string 1, paste 2 string 2, but here is the difference here. We're saying the separation between these two strings is going to be a comma and a space. And that should then read, R can be intimidating, comma, space. However, R is a powerful tool, just like a regular sentence would read. Okay. Another way, so that was using paste. Another way to concatenate variables is using C. I assume short for concatenate. So say, for example, we have a string of numbers here, all within this C function, and we've assigned it to this variable called numbers. Out pops out a string of these numbers. Same with the text. We've created a string of text, which happen to be different fruits. We can then string those two together. Here's another example where we've stringed together string 1 and string 2. And you'll notice that it's listed differently than what we've worked on over here with paste. Okay. Okay, so next we've kind of jumped ahead a little bit in previous because we've talked about character strings, numbers. So this is where we're kind of get to the bottom of that, and that is what is called data types. And the next slide as well, we'll work through different data types. So the first one being vectors, and that's what we were just working with. They're one-dimensional sequences of elements of the same data type. They are really the most basic data structure in R and form the building blocks for other structures that are following on this slide. So from vectors, we move on to matrices. They are two-dimensional, rectangular arrangement of elements similar to a table where all elements within the matrix must be the same data type again. So that's speaking to they must all be numeric, they must all be characters, they just all must be the same. They have a fixed number of rows and columns. And then finally, data frames. These are two-dimensional as well, rectangular data structures that can store columns of different data types. So this is different from matrices where every single column and row had to be the same data type. Data frames allow you to have a bit more freedom. You can have a column of numeric, you can have a column of characters or factors. So this is, I think, what we're all really used to, working in Excel, having multiple columns of different types of data. This is the most commonly used structure for storing tabular data. Each column in a data frame can have a different data type. Okay. So let's just work through some examples here. On the left, we have vectors. So this first example here, we're creating a vector using this function called sequence or seek. And we're saying seek numbers 1 through 10, and we want by 1. So it's from, to, by. So the output here of var1 is the numbers 1 through 10. Same thing for this next example. We've seen this before. We're using the sample function 1 through 50 and sample 10 numbers from numbers 1 through 50. And this is our output here. These are all vectors. And finally here, we're again seeing the concatenate function here, stringing A through J together, and that is a vector. If we go over here, we're now looking at matrices. So in this function called matrix, you give it the data, the numbers, or whatever you want to fill the matrix, and you define the number of rows and the number of columns. And so you can see now we're having numbers 1 through 10, still using the function seek, 1 through 10, but now you can see that it's organized within a matrix. And these two examples here are just showing how you can play with the dimensions of a matrix just using the n row and n col arguments. Okay, and then finally, data frames. So one way in which you can create a data frame is using the function data.frame. We're creating a data frame here called df_1, and we're making 3 columns, var1, var2, and var3. And each one represents what we saw earlier when creating vectors. So the first var1 will be, again, 1 through 10. var2 is the 10 sampled numbers from 1 through 50. And then finally, var3 is A through J. Hopefully, what you're noticing is that each of these vectors, var1, var2, var3, are the same length. And that is the only way this function works. If one vector in here is one more element longer than the other, you'll get an error. Okay, so remember in the previous slide, we've already created these vectors, right? So these are in your environment. A shorter way that you can do this is just say this column name of var1, it's going to equal that vector that we've created. Same with var2 and var3. You don't have to spell it out within the data frame. You can create the vectors first and then feed the vectors into whatever sort of column name you'd like. I just happen to use the same column name as what the vector is called here. Okay, so now you will see here that both df_1 and df_2 look to be the same. 10 observations, meaning 10 rows, 3 variables, 3 columns. Okay, so now we're kind of zooming all the way in now and talking about variable types. So I've kind of been speaking about some of these like numeric or character, but let's work through these. So there are a number of different variable types. First one being integer, which are whole numbers. So that will be like 1, 100, -9. And that differs from numeric, which you'll see more decimals. So we'll see 0.1, -0.09. These are numeric. You will never find integers with decimal places here. Character strings are text. It's pretty self-explanatory. A, hello, welcome, words, a string of words, a sentence. These are all characters. Logical. This is where you can start to play with if-else statements. And so a logical would be either true or false. Factors are best known as categorical variables. And so you can interchange from a character, say just green, blue, red, but for some reason they have to be categorical. You can change that to a factor. And then finally, missing values, and that is NA here. Sometimes you'll see in Excel sheets 9999 or blanks, but it's best to use NAs. Okay, some operators. We've worked through a few of these, but there's a bit more to work through. Arithmetic operators, really, they all are quite the same in just basic math, plus, minus. The stars multiply, that slanted sign, it's divide, and then the raised, or the caret. We've worked through the assignment operator, so you'll have the arrow or the equal sign, although most folks use arrows. Extraction, or what is called indexing. That's when you can take out or replace part of an object. You can use what's called square brackets to index, say, vectors, or, well, in data frame world, you often use the money sign. So if, for example, say you want to extract a column within a data frame, you would say data frame money and then the column name. Okay, and lastly, we have the logical operators. So this is where it's very helpful within, say, an if-else statement to ensure something is true or false. There's the greater sign, the less than sign. If you want something, if you're asking for something, if something is equal to some sort of value, you use double equals. And the double equals is, the reason we use double equals, I think, is explained more. So if you want to say does not equal, we have the exclamation mark, which means not usually, and equals. So that's why we see a double equal sign, because you'll interchange the first one with an exclamation mark. So equals or matches is equals equals, while does not equal or does not match is exclamation mark equals. And then a few more here. When you want to say check to see if this, if some variable values, if the rows within if the rows within a column and the rows within another column equal something, you would use and, which makes sense, but or is a little a bit more hard to remember, and it's this vertical line. So and is the and sign, while or is this vertical line. Okay, so just to walk you through what indexing looks like, especially when it comes to indexing vectors versus matrices. Again, indexing is the process of selecting specific elements or subsets of data from various data types. Our users one-based indexing, meaning the first element is at index 1, unlike any other language in Python, which uses zero-based indexing. So that's just something to note, especially if you also code in Python. But just for your example here, if you remember back, we had that vector called fruits, which was apple, banana, and I forget the last fruit, maybe pineapple. But if you say fruits and we want to index the second element, that's what the 2 here means. We're grabbing whatever that second element was, and that happened to be banana. In var 1, this example down here, we're indexing the 6th element, and that happens to be 6. Okay. When we're indexing from matrices, we have to indicate the row and the column, especially if we want a specific value. So if we say we want the row 5, column 2, that gives us the output, which is a 10. Okay, and similar example down here. Row 1, column 5. Okay, lastly, I wanted to point out how you can index an entire row or an entire column. So this is indexing, again, it goes row, column in the square brackets for matrices. So this is saying in matrix 1, let's index column 1. Whereas here in matrix B, we're saying index row 1. Every single number within that in that row. Okay. Alrighty, so then lastly, when it comes to indexing is indexing data frames. And again, when it comes to data frames, we use the $sign. So here, for example, if you remember back, we created df_1. If you use the $sign and then call out variable 1, what comes out is what's that vector that we created a while back, which is just the numbers 1 through 10. And if you type out df_1 money sign and just pause there, R is smart enough to help you, and it brings up this window of the different variable names within that data frame because it's in your environment. So it's giving you a little hint, just kind of like a shorthand trick, to then you can click on whichever variable you want to call on. Okay, so we're going to pause there, but those are the main coding and syntax basics when it comes to coding in R.